ಬರೋಣ ಅನ್ಕೊಂಡೆ ಸರ್. ನಿಮ್ದೇನಾದ್ರು ಪ್ಲಾನ್ಸ್ ಇದೆಯಲ್ಲ ಬೇಡ
No problem. What time you're coming, you tell me.
ಸರ್. ಫಸ್ಟ್ ಹಾಫ್ ಬರ್ತೀನಿ ನಾನು ಅಲ್ಲಿ. ಒಂದ್ ಸ್ವಲ್ಪ ಪರ್ಸನಲ್ ಕೆಲಸ ಇದೆ ಒಂದು ಆಫೀಸಲ್ಲಿ. ಸೊ ಅದು ಮುಗಿಸ್ಕೊಂಡು ಐ ವಿಲ್ ಕಮ್ ಆನ್. ಅಲ್ಲೇ ಹತ್ರ ಅಲ್ಲ ಸರ್, ಭಾಷಂ ಸರ್ಕಲ್, ಶಂಕರ ಮಠ ಎರಡು ಹತ್ರ.
Hmm.
ಓಕೆ ಸರ್, ವಿ ವಿಲ್ ಪ್ಲಾನ್ ಸಾಟರ್ಡೆ ಮಾಡಿ.
Right. Okay, let me get back to this moment. So, ಮಾಡೋಣ ಪ್ಲಾನ್. ಏನು ಅಲ್ಲೇ ಬಂದು ಹೇಳಿ ನನಗೆ ಎಷ್ಟೊತ್ತು ನಾನು ರೆಡಿಯಾಗೇ ಇರ್ತೀನಿ. ಐ ಕಮ್ ಇನ್ ಮೀಟ್. Anyways, let's just go into ನೋಡಿ moments. So again, you see the event. The event produces the data. This data is the distribution. Now the obvious raw question was, what do you do with the distribution of data? Obvious things that you can find out are your first thing you will do mean, then median, then mode. Mean and median both are important for its own reason. They are important to be found out. And also the beauty is, when given a raw distribution, the only reasonable intelligent thing that you can do with raw given data is find these two. Once you get the mean, this acts as a reference, second reference, or actually the first reference of the distribution itself is the mean. With respect to the mean, you will build the next drama. Correct, Manjunath? You're seeing, observing this?
ಎಸ್ ಸರ್.
What is this? ಯಾವ ನಂಬರ್ ಐತಲ್ಲ, 14548. Remember this?
ಎಸ್.
Then mu is equal to ಎಷ್ಟದ? Vikas, any idea? You remember that? 4?
4.4, sir.
4.2 na?
4.4.
4.4. Oh, very good.
4.4.
4.4. From here the drama starts, no? Because you found the mean. Now with
Yes.
respect to mean, the difference of this, then square, then you get the variance, then make square root, you get the standard deviation, then you put the standard deviation here, you again the mu here, different. Everything is getting expressed in terms of the mu, the mean. Correct? So
Yes.
so that is why this mean, median, and modes are called the measures. Measures of central tendency. The tendency of the whole distribution around this center. Mean, median, and mode. That's what they talk about. Fine. That's what they did. That's what they observed. But after a while, when you look back, see, we went from mean, median, variance, standard deviation, then we came to PDF, probability density function. And functions, whatever it is, when plotted, have shapes. I mean, that's the nature of it. Because a function is a map, mapping is visualizable, viewable. So that viewable has a shape, have shapes when plotted. Agree with me, both of you? Functions have shapes when plotted, correct? Because when you plot it, you put variables in it, you will get some curve, correct? Now the PDFs, another problem of PDF, or another opportunity. You see, an opportunity came up saying many distributions, some go like this, some go like this. These are all probability spaces only. Not everything will be like this. This is more likely to happen. Some will go like, right? Some will be like, okay, both of you, all of you are getting this one picture? When I'm writing
Yes, sir.
this, what am I writing? What is this whole thing?
Density.
Sample space.
Sample space. See, Manjunath, It is a
It's
density, but I hope you connected that
to the
with the
plots.
sample. ಯಾಕಂದ್ರೆ
Yeah, plotting the my
ಹಂಗಲ್ಲ ಮಂಜುನಾಥ್, ವಾಟ್ ಐಮ್ ಸೇಯಿಂಗ್ ಇಸ್, ಇಲ್ಲಿ ಏನಿದೆಯಲ್ಲ ಈ ಜಾಗ ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ ನಿಮ್ಗೆ,
uh,
ಈ ಜಾಗ ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ,
empty space.
ಎಂಟಿ ಅಲ್ಲ ಅದು.
There is a fill of data. Now in drawing, it's an empty space.
ಎಂಟಿ ಸ್ಪೇಸ್. ದಿಸ್ ಈಸ್ ದಿ ಇವೆಂಟ್.
Okay.
ಈ ಇವೆಂಟ್ ಅಂತ ಹೇಳ್ತಿರ್ತೀನಲ್ಲ ನಾನು, ವಾಟ್ ಐ ಕೀಪ್ ಸೇಯಿಂಗ್
So,
ಆಲ್ ದ ಟೈಮ್,
so
ದಿಸ್ ಇವೆಂಟ್,
the
ದಿಸ್
outer
ಇವೆಂಟ್.
line is itself event.
The inside, all possibilities in that event is captured
Okay.
by this curve.
Okay. Okay. Whole event is captured in that particular map
Volume.
itself.
In this volume. Correct, no? Because that's how this became
Okay.
34%, 34%, 16, ಎಲ್ಲ ಆಡ್ ಮಾಡಿದ್ರೆ 100% ಆಯ್ತು.
Okay. Okay. Got it, sir. Got it. Got it. Got it.
So that is what they are trying to model. Okay.
Yeah. Whole event is converted into the particular plot.
ಈಗ if you want to check the shape of that, now there are some more opportunities for us to explore by measuring ಇಷ್ಟೆ. Once you measure the shape of PDF, you sort of redefined a new way of looking at statistics using something called moments. Okay. Like how first was what? First was measures of central tendency. This was mean, median, mode. Moments, measures of central tendency were 3. Moments are actually 4. What are those? The first moment is the mean. You already studied that. The second moment is the variance. The third moment is the skew. Okay, and it what a skew encompasses is, it is trying to tell you how lopsided is the distribution. A distribution with a longer tail on the left, will be left skewed. Skew is like skating, so remember it like that. Skew is here. This is the skew. This is not the skew. Where it is pointingness is not the skewness. Where it is sloping down is the skewness. Say, this is the skew. Skew. Okay. Skew. Where it is right side, right skewed. Where is it going to the negative axis? Negative
So
skew.
one question, sir. Sorry to interrupt you.
Mm-hmm.
So how we can identify the skew? This space is skew and this space is not skew.
Where? Tell me, give me an example.
So here in the graph itself, it is plotted as a negative skew, and that is another way as a positive skew.
Hmm.
How we arrived this is a positive skew and it is a negative skew. So I can tell also, right, something will be there, right, to identify it's a negative skew or it's a positive skew, like that. So I can make it reverse also. I can call positive skew. This is the one what you mouse is pointed out, but I can say this is negative skew.
No, that is why I'm saying this is the skew, not this.
Okay.
Skew andre idu.
Okay. Skew
Okay.
andre idu. Okay.
The meaning of skew is this. Where is it skewing towards?
Yeah, native skew.
Negative.
Yeah,
So the skew is towards the negative. Here the skew is towards
positive.
positive.
Yes, sir. Now I got it.
Now we will also understand one application of this. Vikash, fine. Any question with that skew?
Yes, sir. Sorry.
Any question with this skew? Like, do you have
No,
any
sir. No, sir.
insights to share also? You can share.
No, sir. Nothing at this point in time.
Okay, okay. Now, let's suppose there is a CET student attending the CET cell. CET cell student is attending the CET cell where he or she has to decide which college to join for, let's say, aeronautical. One college's aeronautical average marks is defined by this Q. One college's aeronautical mark, okay, defined by this. This is the average marks. College A, college B. Which one should this student choose? Both options are there for him.
Positive skew only.
Positive skew means here. Hmm?
Yes. Yes, B.
Hmm. How?
How I think is this is falling into the positive. The skew is falling into the positive. So if I choose the college, it will be in the positive side. So that's why I choose the B college. And A college is still falling into the skew is still going into the negative. So it will keep on going into the negative, and one skew is constant, and it is no growth there. So that's what I won't choose A.
Vikas?
Actually, in the second, actually in the second one, that is for B college, there are a lot of students who have a score higher than the average.
Correct.
Yeah. So as the score keeps on increasing, the number of students gradually decreases, but still, there is significant competition for college B. Whereas if we see for college A, uh, so it is like a lot of students have scored below the average value
Yes.
because of the long tail that we have
Yes.
towards the negative. So one thing here, sir, is depending on the marks of the student, he'll be able to make a call. But if he's looking for more competitive environment, then B is a better
No,
choice.
for him
And
the
if he's look,
marks, for him the
yeah,
marks, for his marks, both options are available. That's all.
okay,
So we are trying to.
understood.
So Manjunath,
Sir,
you understood the interpretation now.
yes, I got it, sir. After Vikash explanation.
So
So
this you have to you have to you have to look at graph and create stories. Okay, you have to get into this habit of looking at graphs and creating stories. Then you come and discuss with Vikas. You can have like let's say 5 minutes record. Take a graph, start your video on, and record something and send that video to the group. We will respond whether you are thinking right or not. Many graphs are there. Okay, whether you are looking at the graph properly or not, whether you are able to read the graph. Because see what this Q thing, Vikash will appreciate. Correct, Vikash? Because just this Q thing has so much story to tell. See how he saw the story there. But of course, see, I'm not saying Vikash is it is Vikash's business to do it because he's from IIM and he's trained. He's a trained eye. So fine, correct. We will take it with that. But still, we also have to learn, no, Manjunath. Like Okay, if
Yes.
somebody is doing it, we have to learn and learn that. We could pick up that trait, correct? So
Yes.
that story building, how he saw that, right? You also have to learn. This is being changing your mind. You are learning a new skill altogether, which requires old skill of coding, yes, but for a new result. Remember that, okay? You have to make a conscious effort. For that, I've given you all those cartoon books and all. So yeah, that have you read that cartoon book?
ಇಲ್ಲ ಸರ್ ಇನ್ನೂ ನೋಡಿಲ್ಲ. So I need to go
That's
through.
the end all. He liked it, correct, Vikash? From your
Yes, sir.
experience
Very.
also, it's a good book, right? To observe and slowly get into the
From the
field.
basics, it was like very nice, sir, actually.
Mm. So it's a very good material, Manjunath. So
Yeah, I will go through.
take it easy. Aram, so you will get it. ಬಂದಿದ್ದಲ್ಲ ನಿಮ್ಗೆ? Have you taken a print of that?
ಇಲ್ಲ ಸರ್, PDF ಫೈಲ್ ಇದೆ ನನ್ನ ಹತ್ರ.
You
I
take
have.
a print. Take a print. And it will cost you 160 or something. Take a print
Okay.
and keep. Hmm? Right. So moments. First moment is around the mean. Second moment is around the variance. Third moment is the skew. Fourth moment, the fourth moment is the kurtosis. Okay. The kurtosis is, let's suppose you have something like this. So we are already looking at this. You see, we are already looking at this, that okay, this is peaking, but here is also there is a breadth of it. Sometimes you will see there is no breadth also. It is just goes here, peaks off, comes off here. So Manjunath, what is this again? What is this space? All
I.
ಸ್ಯಾಂಪಲ್ ಸ್ಪೇಸ್ ಓನ್ಲಿ. ಏನೇನ್ ಆಗ್ಬೋದು ಆ ಇವೆಂಟ್ ಅಲ್ಲಿ ಅದು ಇಲ್ಲೇ ಇದೆ ಅಂತ.
Okay.
ಆಯ್ತಾ, ಇದೇನು ವ್ಯಾಲ್ಯೂಸ್ ಇದೆ ಇಲ್ಲಿ ಮ್ಯೂ ಹತ್ತತ್ರ ಮೇ ಬಿ ಒಂದು 0.3 ಸಿಗ್ಮಾ 0.3 ಸಿಗ್ಮಾ ಒಳಗಡೆನೆ ಎಲ್ಲ ಆಗೋಗ್ಬಿಡುತ್ತೆ. ಅಂದ್ರೆ ಬೇರೆ ಬೇರೆ ವ್ಯಾಲ್ಯೂಸ್ ಆಗೋದೇ ಇಲ್ಲ
Event is
ಅಂತ.
very small. Event is
ಹಾ,
very small.
ಎಸ್, ಇವೆಂಟ್ ರೇಂಜ್ ಇಸ್ ವೆರಿ ಸ್ಮಾಲ್.
Range is very small. Yeah.
Event small illa. It can be an event. This can be an event which was observed for 1 year. This can be an event which was observed for 10 years. So when you
Yeah.
say
Event
event
range
is
is
small,
small.
it is no, I'm not saying that. This is a longer
Okay.
event, but its behavior is small. Hmm? Its
Okay.
its range of operation is small. So when you so obviously you see this shape. Of course, whenever you see different shape, what do you want to do? You want to measurement, correct? You want to measure, correct? That's the whole idea. So what did I say was the mantra? What to measure? What you need before measurement? What you need?
Event data.
Okay, ಆಮೇಲೆ ವಿಕಾಸ್
So we need a reference.
reference.
Reference that.
And here, what is the reference? Vikas?
One is that, as you said, the peak is one, and the width.
No, 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 no. Okay,
Range.
okay, okay. I'll tell it. We need this reference.
Bell curve.
Oh, the normal distribution.
Yeah. So how sharp is the peak? How long is the tail? This and this. The ratio of these two, one metric which says this and this, that gives you a number which is kurtosis. With respect to how sharp is the peak and how wide is the tail with respect to the normal distribution. Otherwise, we will always be looping around defining. According to me, this is sharp. This is not sharp. According to someone else, this for me this is sharp. I believe this is wide, right? Who will define? So you need one reference, right? But let's just agree that this is a given normal distribution. With respect to it, how it is behaving, we will measure. So see, what I'm trying to say is there are endless, measurements like this. If you live another 50 years, you will see more. People will come up with metrics like crazy. But I want you guys to understand that people have to come up with metric. You can also define a metric if you want. If you really sit and say, I'm going to change the way in which I will observe data and my measurements will be different, you can, as long as you substantiate it. Saying, yeah, my measurement method is different. Who knows? AI might, they are working on it. AI can help you actually bring out different kinds of references and measurement systems. That's what the next thing is. So yeah, so that's what I hope you get the idea. So instead of simply looking at the event and saying what are the central tendencies, you can see the probability density function and ask what are the moments. In that, the first moment is around the Manjunath, first movement. You think of moment as first movement, first reference ಯಾವುದು?
By relating to the PDF,
ಇಲ್ಲ ಇಲ್ಲ ಫಸ್ಟ್ ರೆಫರೆನ್ಸ್ ನಾವು ತಗೊಂಡಿದ್ದೇನೆ ಮೆಜರ್ ಮಾಡಕ್ಕೆ when I
mean,
say
mean value.
ah the first movement was around the mean ಅಂದರೆ moment, the first moment of understanding about the distribution came when you found the mean, correct?
Yes, 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 yes.
ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಸಿಕ್ಕ ಮೇಲೆ ಆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಇಂದ ನಿಮಗೆ ಫಸ್ಟ್ ಸೈನ್ ಆಫ್ ಇಂಟೆಲಿಜೆನ್ಸ್ ಸಿಕ್ಕಿರೋ ಕೊಡೋ ಯಾವ ನಂಬರ್ ಮೀನೇ ತಾನೇ ಅದು
Mean, yes, yes. First step is mean only.
ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಹಾ ಫಸ್ಟ್ ಮೀನ್ ಇಂದ ಯು ಡಿಸೈಡ್ ಫಾರ್ ಸಮಥಿಂಗ್ ಆ ಮೀನ್ ಬೇಸಿಸ್
Yes,
ಮೇಲೆ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ವಾಟ್ ಯು ಡೂ
we will find the sigma and standard deviations.
ಅದು ಇದು ಅಂದ್ರೆ ವೇರಿಯನ್ಸ್ ಓಕೆನಾ ನೀವು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಡಿವಿಷನ್
Variance,
ಹೇಳ್ಬೋದಾಗಿತ್ತು
yeah,
ಬಟ್
variance. That is called variance. Yes,
ವೇರಿಯನ್ಸ್ ಕರೆಕ್ಟ್ ಹೌ ಸ್ಕ್ಯಾಟರ್ಡ್ ಇಸ್
yes,
ದ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಯು ಟಾಕ್ ಸೊ ಸೆಕೆಂಡ್
yes,
immediately after finding variance, you'll get standard deviation. So, if because you have the mu and the standard deviation, you obviously have the PDF, correct? Once you have
yes.
the PDF, you have the third step, which is the skew.
Skew. Okay.
Then,
Oh,
after
skew.
the skew, fourth is kurtosis. So, you can remember this.
So, can you share the snapshot of this?
In fact, I will make it better and share now only.
ಸರ್ ಈಗ ಕ್ಯೂಟಿಸ್ ಅಂತಂದ್ರೆ ಅದನ್ನ ನಾವು ಕಲ್ತ್ಕೊಂಡ್ವಾ ಅದು ಕ್ಯೂಟಿಸಿಸ್
Kurtosis, ಈಗ ತಾನೇ ಹೇಳಿದ್ ನಾನು ಈಗ ತೋರಿಸ್ತೀನಿ ತಾಳೆ ಗೊತ್ತಾಗುತ್ತೆ
ಓಕೆ
ಇಲ್ಲಿ ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಲ್ಲ then you through examples you will remember the story. This one you remember.
ಯಾ ಸ್ಕ್ಯೂ ಯಾ ಸ್ಕ್ಯೂ
Hmm?
ಯಾ ಗಾಟ್ ಇಟ್ ದಿಸ್ ಒನ್ ಐ ಗಾಟ್ ಇಟ್
ಯಾವ skew? Negative skew or positive skew?
ದಿಸ್ ಇಸ್ ಪಾಸಿಟಿವ್ ಸ್ಕ್ಯೂ
This is
ಲೆಫ್ಟ್ ಸೈಡ್ ಇಸ್
positive.
ನೆಗೆಟಿವ್
Kurtosis ಅಲ್ಲಿ ಏನು ಮಾಡಿದ್ರಿ? I will not do, I will come here, I will take this picture and then I'm going to copy this, paste. ಈಗ ಅರ್ಥ ಆಯ್ತಾ?
Hmm. So normal, ನನ್ಗೇನ್ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಹೇಳ್ಬಿಡ್ತೀನಿ ಸರ್ ಕರ್ಟಸಿಸ್ ಅಲ್ಲಿ. So you have a plot, a skew. Okay, so in that skew you are comparing with the normal plot,
But
normal
no, no,
distribution
no, no.
plot.
You tell me, do you have a skew or do you have a PDF?
I
What
have a,
you,
a PDF.
why you can't have a skew? Skew is a number. You're
Okay.
understanding? Skew is
Yes.
what? You find the skew of this, it will give you a number. So now I want want you guys to do one thing. See, you have been taught and we have discussed enough. Now you go, and I'll give you, of course, the recordings. Now you go to your IPYNB notebooks and you will find another full, this is it, okay? You go and download this hands-on statistics.zip. In
Okay.
this zip file, you download the whole thing. You don't do the matplotlib, don't do any plotting. I will teach you, the whole thing is different. I'll again reiterate statistics. I'll show you all these stats working, okay? Not simply graphs and writing and all the time. Fine, I'll show you. But I want you guys to go and at least check how to find the mean of something, median of something, skew of something, curtis of something. It's all there. Examples are already given. If you don't want, you can Google and go to documentation of NumPy. You'll get that also. Okay, numerical Python. No, of course it has stats in it. So NumPy will have stats methods. Just go and check, and by the time it must be pretty intuitive. I am here to teach you the interpretation of stats itself. So the next time when you are sitting and you've been given the task of reading a mega book or mega paper, this is the life tomorrow. You are entering a subject which is data science, machine learning scientist, machine learning engineering, taught on a daily basis, and every day its complexity increasing will be your natural disposition. Is supposed to be your natural disposition. So you will have to. It's not difficult. You have to change the way. That's all. That's the reason why I told Manju. It's a long curve for you, but keep at it. I am very positive that the kind of person you are, you will get better at this also. Okay, you are a
Okay.
challenger. You enjoy solving problems, right? You're a problem solver. How does it matter which problem you're solving? Correct? No. You just want to
Yes.
solve a problem which pays you better. Correct? Correct? Isn't it? Correct, Vikas? You have the brain. You want to solve a problem which gives you highest return on investment. Correct or not?
Right, sir. Yeah.
So basically,
Right.
that's the whole idea. So I'm gonna. I don't know. These are not like well structured, well made pictures, but my graphic design, my writing and everything is not that good. So you'll have to just adjust. But do you guys agree that it's better for me to write and talk, or shall I bring those beautiful PPTs, which is just PPT? This is better, no? So that there is time for you guys to, think along and look and think along, right? This is better, writing
Yes.
and thinking. Chalo. So we have done this, we have done this, we have done this. Fine, everything is fine. So now there's one thing which we'll see whether let's read this at least. Let's read this. Quantitative measures of shapes of probability density function. That's what it is. It's a quanti. You have been able to quantify the shape of the PDF itself. That's all. Okay. So fine. It's a good statement, right? Intuitively, it's a lot simpler in statistics. Intuition. Otherwise, equation your package will know. Okay, you can also go and check what is an equation. Finally, what are the variables? What are the constants? That's all is there in an equation. So what are the dependent variables around which the what constants are, keeping it in check? You see, and what are the range, right? Okay, it is from here to here. Fine, you got that, and you got the equation. Let it be. Uh, but intuitively, in mathematics, a moment is specific quantity to measure used in both mechanics and stats of the shape of a function. If the function is a probability distribution, if the function is a probability distribution, then the zeroth moment is the total probability. Otherwise, whatever I told next is already I've told. First moment is mean, second central moment is variance, third everything I've written. This is the one which you are supposed to understand. If you understand this statement, then so far whatever you know we have been doing, this is the end. I mean, if you want a benchmark as to whether you have arrived at the scene of data science, you have to understand this. The zeroth moment is a total probability. Nobody calculates the zeroth moment, by the way. You don't need to calculate the zeroth moment. There is no meaning to calculate zeroth moment. What is the fun when there is no moment at all? Zeroth moment means what? When there is no moment. When is there no moment? When? When is it that there is no moment? This is when. When you ask what kind of, when means what? What kind of data experiment will have no moment at all? An experiment where you are asking 1 lakh people how many heads they have, how many heads on their shoulders, right? How many heads they have is we are asking. What will be the answer, ಮಂಜುನಾಥ್, ಫಾರ್ ದಿಸ್? 1 ಲಕ್ಷ ಜನಕ್ಕೆ ನಿಮ್ಗೆ ಎಷ್ಟು ತಲೆ ಇದೆ ಅಂತ ಕೇಳಿದ್ರೆ ಏನ್ ಆನ್ಸರ್ ಇರುತ್ತೆ?
1 ಲಕ್ಷ ಜನ 1 ಲಕ್ಷ ತಲೆ ಅಷ್ಟೇ ಸರ್.
ಎಷ್ಟು? ಎಲ್ಲ ಒನ್
ಹೌದು ಸರ್. ನ್ಯಾರೋ, ದ ಡೇಟಾ ಇಸ್ ವೆರಿ ನ್ಯಾರೋ.
ನಾಟ್ ನ್ಯಾರೋ. ಆ ಥರ ಹೇಳಿದ್ರ ನೀವು? ಓಕೆ ಓಕೆ ಓಕೆ, ಫೈನ್ ಫೈನ್ ಫೈನ್, ಐ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. You have your own way of expressing, seeing things. Slight changes I'll do, but finally, eventually, you'll have your own intuition on it. Fine. I'm training your intuition to give you the right intuition. See, person one, person two, also one, person three. How many heads? Person three, same. How many heads
ಸೇಮ್.
person four has? Same.
ಸೇಮ್.
How many heads person five has? Same. How many heads per? So this is a flat distribution, uniform.
ಓಕೆ, ಫ್ಲಾಟ್.
Anything is one only there. So when
ಓಕೆ,
there is no movement at all, that is the total probability.
ಓಕೆ, ಓಕೆ, ಓಕೆ. ಸರ್ ಇವಾಗ ಇಲ್ಲಿ ಎಕ್ಸ್ 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 ಹಾಕಿ ಸರ್, ಅಲ್ಲಿ ಮೇಲ್ಗಡೆ ವೈ ಹಾಕಿ.
Hmm.
ಸೊ ವೈ ಇಸ್ ನಾಟ್ ಅಟ್ ಆಲ್ ಚೇಂಜಿಂಗ್.
Correct.
ಈ ಒಂದು ಎಕ್ಸ್ ಚೇಂಜಸ್ ಆದ್ರೂ.
Super. ಅದೊಂದು ಒಳ್ಳೆ, absolutely no change in y. So if there is no change at all, that is zero change, no?
ಜೀರೋ ಚೇಂಜ್.
See, very nicely said. See, I didn't know this. You are now getting there. Because anything you want to add or slightly.
No, sir. Actually, that I was just looking at the math formula that you had shown, that
Hmm.
integral from minus infinity to plus infinity,
All
x
possibilities.
right, x minus c power n into f of x dx. So
Hmm.
when n is equal to 0, it will simply give you integral from minus infinity to plus infinity, so which will give you 1. So I was just trying to interpret that part in the presentation that you had shown.
Yeah, this one. Okay, when n is
Yeah.
equal to 0,
Uh,
it is x minus 1. So,
c to the power 0, it will be 1.
yeah. So this one becomes a constant.
That term
No,
becomes 1.
yeah. So
It
your,
becomes 1.
yes. N is what here?
N would be 0, sir.
Zero, the
The
moment,
moment.
the moment, yeah, fine.
Yeah. So it will be integral
So,
f of x dx, which is nothing but the whole curve itself. So it will be 1.
nice. So everyone has your own way of getting the this one, but you guys understand that now you're understanding zeroth moment is a total probability. You keep looking at it. You next year you'll have a better understanding of this. Okay, so this should be your benchmark. This one, and because you also get to your own understanding of this, and something very interesting for you to do at your level. Okay, is you will now write an article on this. Your explanation of this. And I want you not to simply write based on what you now know. I want you to write it based on a little more research. Not research in the sense research other people, other things. Little more
Mm.
thinking. Think for this week and come up
Okay.
with your own understanding of it. Okay, you write that article. We will publish that article in your name. Okay, and we'll link your LinkedIn profile also to that article.
Yeah. Okay, sir. Got it.
So that should be the best way to go forward. Actually, this most people won't understand it. I hope you realize now because it's not obvious. This is not obvious.
Mm. Right, sir. Yeah.
So you have to make it. That's what your work will be in having that kind of clarity. That's what your work should be. Today is a holiday. Is it a holiday today for you guys?
No, no holiday, sir. No
No,
holiday.
sir. No.
Okay. So shall we just go ahead and finish covariance and then we close?
Sir, time ಆಯ್ತು sir.
Okay,
No.
tomorrow we'll do covariance, and after that, tomorrow is it's a small topic covariance. Then I will not do conditional. I will not get into conditional probability now. It we will do graphs and everything. Tomorrow is covariance and matplotlib. Okay,
Okay.
tomorrow we
So
are doing
already
plotting.
9:30 I would.
Right, right, right. Go ahead, go ahead. Fine.
Prakash, are you need to rush for office?
No, I'm actually working from home, Manju. So for me, not much of